and getting that installed. Spectacular EVA, and it worked out really well.
So 2 of those assembly tasks were done with a combination of robotics and spacewalking. Another one of our assembly tasks was taking that stowage platform and putting it on the space station, and we did that totally robotically. So we took it out of the bay with the shuttle arm and handed it over to the station arm, and the station arm took it closer to the station, and then using computers, we sent commands to the latching to latch the ESP3 or the stowage platform onto the station. It's pretty interesting and a lot of fun flying the robotic arm. It's like geometry in action. It's great fun, and it's also quite challenging. When you are looking out the windows and making sure you're not running into anything, you're paying total attention to it.
One of the key features of our mission was the fact that it was an educator-astronaut thing, and before that was the Challenger mission, and we got a chance to talk with one of the Challenger centers while in orbit, Barbara and I. It was special for us.
Okay. We also had some teachable moments, and we hope to be able to share those with students. The thing that we are most excited about education-wise on our mission is something that will grow and grow, and it's for students to do here on Earth with their teachers or with their scout leaders and other groups like that. We took up 10 million basil seeds with us, and they are returned now. We're getting them packaged up, ready to send out to classrooms all over the country. And we want our students to do what we get to do. Don't take a test. We won't give you a test on it, but we want you to experiment, explore, figure out what you want to know about these basil seeds, especially in terms of how we're going to feed people on the moon and Mars for long duration. And so we hope you'll be able to design some growth chambers for us.
And I was very happy those basil seeds didn't get loose.
Now, before we ever go out the hatch doing an EVA, there's plenty of work to be done beforehand. Suiting up the guys and doing their pressure checks and making sure that they get buttoned up inside the crew lock securely. You see here a few of us doing some handshakes, getting tools on these guys and configured to go out the door. I think this is the beginning of EVA 3, and in that time frame we did a number of tasks, moving antennas as well as removing and replacing boxes such as baseband transponders and signal processors, as well as moving the CETA carts, which are work platforms that ride along the front face of our truss segment. We have 2 carts, and we had to relocate them from one side, I think the port side, to the starboard side, and that was in preparation for the upcoming missions that are going to be installing elements to the port side.
And like Tracy said, on EVA 3, one of the things we had to do was move the SASA gimbal. It was basically a communication antenna way up on the top of one truss, and we moved it to another truss. And that's in preparation to move that whole piece of truss. The second big task was having, this is Clay Anderson hanging onto a CETA cart, again moving it to the other side of the space station in preparations for some future construction work. You can see there's Clay on the end of the arm. You can see it's a heck of a ride up there with some beautiful views. This is Clay's up-close helmet cam as he takes my picture as we circle around the world. And then we had a little bit of a snag on EVA 3. We had to cut it a little bit short because I had some hand-intensive EVAs, and over the time the glove got cut over in the thumb area. You could see it there. So once we came inside, Clay and Dave got some close-up shots of the glove, and we sent them down to Houston so they can analyze it a little closer.
At this point, we were trying to figure out how to maybe extend the flight to repair the small amount of damage we had in the bottom, but then Hurricane Dean popped up, and we had to figure out how we were going to cut the flight short. It was a impressive sight from the space station. Got some had some incredible passes over it, and then decided to do EVA 4.
EVA 4 was pretty exciting for us. We knew ahead of time that it was going to be a little bit shorter than normal. We were getting ready to close the hatch right after the EVA. I came out first and had a spectacular view of the world coming out at daytime, but we had a little bit of a challenge because in the airlock we had so much equipment that my hand control module for the SAFER actually deployed. So one of the first tasks of the EVA we hadn't really planned for was for Clay to put that back, and you'll see a close-up photo of that as Clay opens the door and gets that all folded up and brought it back inside and got it all set for me. Once we did that, we basically hit the ground running, and the first part of the spacewalk was to install some stanchions for the boom system that we're currently using for inspecting the orbiter. Clay and I translated or moved hand over hand up the CETA spur and had these large pieces of equipment attached to us, and we installed those on the station, bolting them in place. Once we did that, we separated, and Clay went to retrieve the Missy experiments, and I was up working on the SASA, tightening up the gimbal locks, and once we had finished both of those two tasks, we again got together, kind of rendezvoused, picked up a fair amount of equipment, and translated out on the lab. Here you can see Clay bringing one of the Missies back in, and you can see how large it really is. He had to remove that and bring it back into the airlock. So we picked up extra tools at the airlock, translated out, and installed two antennas. They're called EWIS antennas that basically enable us to capture the images from our helmet cameras to see spectacular images like this of Hurricane Dean. And that pretty well finished up EVA-4. We had one other get-ahead task that we did, wire tying some cables back into place, got back in the airlock and closed the hatch, came back inside and got ready to close the hatch of between the vehicles.
As you can tell, all good things must come to an end, and there we actually closed the hatch the day before. We made sure we had everything on the right side of the hatch. In fact, we had opened and closed them a couple times just to make sure we had everything. And up till we get to this moment in the following morning of actually separating away from station. Because we had to do an inspection afterwards, we didn't actually do a fly around where you actually circle the space station and take pictures of it and photograph it. We actually just separated out and did an early separation burn. And it was actually a pretty neat thing to do because we got to take some really great hands-off pictures of the station. It was actually a lot of fun in the windows where usually you'd be worried about making sure you're at the right distance and doing everything right. We're just separating out and kind of spiraling out and just having a good time watching it all happen. And in the meantime, we're getting ready for that late inspection. I actually got to do this event, even though I'm called the pilot, I'm really the co-pilot. And so Scott does the docking. I get to do the undocking, and then he does the landing. I had a lot of people ask me that told me the landing was great, and of course I just accepted that. But if they told me it was bad, I said, hey, it was Scott.
Here's views from inside the cockpit on entry day. We get, again, suited up very early for entry, several hours prior to landing.
I'm down one. 12,000. Okay, my overlays.
Here's a picture of us lining up on the runway. Most of the audio here is Scorch.
Like about 7.
Actually,
2,000. Pre-flare. Pre-flare, arm the gear. Gear's arm, got a light.
Being a very good co-pilot.
3,000, 307 max. 9.
Talking me through the landing.
7, 6, 5. Gear 3. 400 feet. Gear's on the way. Good energy through the threshold. You're on the ball bar. Good job. 5240, 4235.
At 40 feet, you can see us pick up a little bit of a drift here.
10220. Good left correction. Your touch.
We intentionally delayed the shoot for the crosswind landing test.
I told him to say that.
It's funny the things you read in the press about why the shoot didn't come out. And here's us underneath the orbiter right after landing, taking a look at, among other things, the damage to the tile, and smiles on our faces.